Hi, how you all are doing? My dear friends, today I am on behalf of Gurudev Academy. We are going to have a discussion on K-CET Physics Code A3 paper discussion. Okay, the paper conducted was today, that is on 16th, and we will have a look at each of the key answers and plausible discussable query related answers for each of these questions. Okay, without much ado, let us go ahead and move on with our first question, my dear friends. So here you can see that in first question we have range of electrical conductivity they are asking and resistivity. So we need not go ahead and scratch our head too much here, because we know that conductivity and resistivity, they have standard values for metallic conductors. So we'll go ahead and pick option 3 here. Then second question, which of the following statement is correct for a n-type semiconductor, they are asking. So clearly the donor energy level lies just below the conduction band. So option 3 is our right choice. Then moving on to third question, in this particular section, in this particular circuit, they want us to find the current. Okay, now in this case D1 and D2, if you just observe, D1 is in reverse bias, D2 is in forward bias. So because of that reason, what happens, only 30 ohm resistance will be effective for the conduction of current. So hence 30 plus 70 would be how much, 100. So hence current I will be equal to what, current I will be equal to EMF is 3 divided by 100. So it happens to be 0.03. Okay, now let's progress with next question quickly. Then in this question they want us to go ahead and take a look at, note that this question is based on your practicals, because it has been announced earlier, and on your RI of glass slab experiment, from that actually we are having. And here you can see that the formula that we will use is N is equal to what, R3 minus R1 divided by R3 minus R2. So clearly C is R3, B is R2, A is R1. So if you just put these values, we should get 1.5000. Okay, so definitely as a commonsensical answer I can directly answer this, but anyways this is the formula that we are going to use. Okay, then fifth question, in an experiment to determine, okay, again this is figure of merit experiment based question, and figure of merit of galvanometer, in that we always write resistance of galvanometer G is equal to what, G is equal to R into S by R minus S. So if you just use this formula according to the given values and put those values, very clearly we will get the answer as option 2, 91.6. Okay, then moving on to next question now, sixth question. Now this is again based on a coefficient of viscosity experiment, okay, which we actually have conducted during our first PUC. Now note that in this particular case we can make use of terminal velocity. Now I'll just write a brief solution for this. So just note here for this question. So terminal velocity based approach. So Vt is equal to, we have the formula, terminal velocity Vt is equal to 2 by 9 r square into rho minus sigma into g divided by eta. Now if you just use this formula and make the calculation, my dear friends, you should get the answer as, okay, any guesses? It should be how much? 0.14 Pascal second. So we should get the answer as 0.14 Pascal second. Then moving on to question number 7 now. In question number 7, it has been asked very clearly which one can be deducted on the basis of dimensional analysis. So our direct answer is S is equal to ut plus half at square, because cos omega t trigonometric function, this is exponential function, and here we have a constant factor in the Stokes formula. So definitely my safe choice would be what? Option 3. Then moving on to question number 8. Now 8th question, actually this is a bit of calculative type of question. So in this 8th question, if you just note, I'll just be writing the solution here. Okay, for 8th question, note that two objects are dropped. Okay, first object, second object, they are dropped from same height. Okay, but this second object, that is object 2, is dropped little later. So hence, when object 1 has reached the height of h1, okay, then object 2 would have reached height of h2 above the ground. So if you just follow this, then I can see that the net height from the ground, now this height should be how much? This height should be h2 minus h1. Okay, then for we know that h1 is equal to what? h1 is equal to half g t1 square, and h2 is equal to what? Half g into t2 square. Now t2 I will be writing it as what? I will be writing it as t minus t naught, because say suppose total time taken is t naught here, then of which t time has been consumed here, so it should be t minus t naught. So you just follow this approach. Okay, you should get your answer as option 2 here. Okay, most probably option 2 we should get. Yes, correct. So in this particular case, our answer is option 2. Okay, so second option is our right choice. Then moving on to 9th question. In 9th question, it is direct question. We can see that horizontal component of velocity is always constant in projectile motion. Then moving on to next question. Now 10th question. 10th question, a particle is in uniform circular motion. So here we can see that here in this question they want us to find what? They want us to find the value of acceleration. Now note that in this particular question, A is equal to what? Acceleration A is v square by r. Okay, and over here according to given parameter, now this equation x minus 2 whole square plus y square is equal to 25. Here r is equal to how much? 20. R is equal to square root of 25, that is 5, because this given equation is equation of circle. So definitely radius of circle is 5, and velocity can be very easily found by using the coordinate here. So hence over here I can very easily get the value of velocity, and if we just simplify this, so we'll get this as, we'll get this value as 2 square by 5. Okay, so 2 square by 5 happens to be option 2. Question number 10, answer is option 2. Now moving on to 11th question. So in this particular question, we can consider two components of tension here, correct? So first component, T sin theta equal to mg, second one, T cos theta equal to mu mg. ನೋಡಿ ಇವಾಗ ಇಲ್ಲಿ ಇವೆರಡನ್ನು ಡಿವೈಡ್ ಮಾಡಿದರೆ ನನಗೆ ಈಸಿಯಾಗಿ tan theta equal to 1 by mu ಅಂತ ಬರ್ತಾ ಇದೆ. ಸೊ ಅದರಿಂದ mu equal to ನನಗೇನು ಗೊತ್ತಾಯಿತು? cot theta. So hence our answer is option 4. Okay, moving on to 12th question now. In this 12th question, ಈ 12ನೇ ಕ್ವೆಶ್ಚನ್ ಅಲ್ಲಿ ನಮಗೆ ಗೊತ್ತಿರೋದೇನಪ್ಪ? mu s ಗೊತ್ತಿದೆ, mu k ಗೊತ್ತಿದೆ, ಆಮೇಲೆ ಫೋರ್ಸ್ ಗೊತ್ತಿದೆ. ಓಕೆ, ಸೊ ದೀಸ್ ಆರ್ ಗಿವನ್ ಇನ್ ದ ಪ್ರಾಬ್ಲಮ್. ಸೊ ಸೊ ಅದ್ರ ಒಟ್ಟಿಗೆ ಐ ಶುಡ್ ಫೈಂಡ್ ಎಕ್ಸಲರೇಷನ್. ಎಕ್ಸಲರೇಷನ್ ಹ್ಯಾಕ್ ತೆಗಿತೀರಾ ನೀವು? ಸ್ಲೋಪ್ ಆಫ್ ವೆಲಾಸಿಟಿ ಟೈಮ್ ಗ್ರಾಫ್, ಅದರಿಂದ ಎಕ್ಸಲರೇಷನ್ ಬರ್ತಾ ಇದೆಯಲ್ಲ. ಸೊ ಹೆನ್ಸ್ ಎಕ್ಸಲರೇಷನ್ ಇನ್ ದಿಸ್ ಕೇಸ್ ವರ್ಕ್ಸ್ ಔಟ್ ಟು ಬಿ, I can write it like this: mu s m into a is equal to, I can mention it as F minus force of friction. Okay, so idralli if you just consider m into acceleration, acceleration a can be written as what? Illi m into bracket namge ಏನು ಬರುತ್ತೆ ಇಲ್ಲಿ a plus mu g ಅಂತ ಬರುತ್ತೆ, ಹೌದಾ? is equal to F minus F. Okay, ಇದನ್ನ ಸಿಂಪ್ಲಿಫೈ ಮಾಡಿಕೊಂಡ್ರೆ ವಿಲ್ ಗೆಟ್ ದ ಆನ್ಸರ್ as 2.2 kg mass. Okay, so this is our answer. Then ಇವಾಗ ಮೂವಿಂಗ್ ಆನ್ ಟು ನೆಕ್ಸ್ಟ್ ಕ್ವೆಶ್ಚನ್. ನಾವು ಕ್ವೆಶ್ಚನ್ ನಂಬರ್ 13 ಮೂವ್ ಮಾಡಿದ್ರೆ ಇಲ್ಲಿ ಇದರಲ್ಲಿ ಏನು ಕೇಳ್ತಾ ಇದ್ದಾರೆ? ನಮಗೆ ಡಿಸ್ಪ್ಲೇಸ್ಮೆಂಟ್ ಕೇಳ್ತಾ ಇದ್ದಾರೆ. ಸೊ ಡೆಫಿನೆಟ್ಲಿ ಇಲ್ಲಿ ನಾವು ಡಿಸ್ಪ್ಲೇಸ್ಮೆಂಟ್ ವ್ಯಾಲ್ಯೂನ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡೋದಕ್ಕೆ ವಿ ಶುಡ್ ಕನ್ಸಿಡರ್ ವಾಟ್? ವರ್ಕ್ ಡನ್ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡೋಕ್ಕೆ ಇದ್ದಾರೆ. ಸೊ ಡಬ್ಲ್ಯೂ ಇಸ್ ಈಕ್ವಲ್ ಟು ವಾಟ್? ಇಂಟಿಗ್ರೇಷನ್ ಆಫ್ ಎಮ್ ಎ ಇಂಟು ಡಿ ಎಕ್ಸ್. ಓಕೆ, ಸೊ ಇದರಿಂದ ನಮಗೆ ವರ್ಕ್ ಡನ್ ಬರ್ತಾ ಇದೆ. ಓಕೆ, ಸೊ ಆ್ಯಂಡ್ ವಿ ಕ್ಯಾನ್ ಸಿ ದ್ಯಾಟ್ ದ ವರ್ಕ್ ಡನ್ ಇನ್ ದಿಸ್ ಕೇಸ್ ವುಡ್ ಬಿ 32 joule. Now moving on to 14th question. During an elastic collision between two bodies question ಇದೆ. ಸೊ ಇದರಲ್ಲಿ ನೋಡಿ, ಇನಿಷಿಯಲ್ ಕೈನೆಟಿಕ್ ಎನರ್ಜಿ ಇಸ್ ಈಕ್ವಲ್ ಟು ಫೈನಲ್ ಕೈನೆಟಿಕ್ ಎನರ್ಜಿ. ಡೆಫಿನೆಟ್ಲಿ ಕರೆಕ್ಟ್, ಯಾಕಂದರೆ ಕೈನೆಟಿಕ್ ಎನರ್ಜಿ ಇಸ್ ಕನ್ಸರ್ವ್ಡ್, ಲೀನಿಯರ್ ಮೊಮೆಂಟಮ್ ಇಸ್ ಕನ್ಸರ್ವ್ಡ್. ಡೆಫಿನೆಟ್ಲಿ ಕರೆಕ್ಟ್. ದೆನ್ ಕೈನೆಟಿಕ್ ಎನರ್ಜಿ ಡ್ಯೂರಿಂಗ್ ಡೆಲ್ಟಾ ಟಿ ದ ಟೈಮ್ ಆಫ್ ಕೊಲಿಷನ್ ಇಸ್ ನಾಟ್ ಕನ್ಸರ್ವ್ಡ್ ಅಂತ ಹೇಳ್ತಾ ಇದ್ದಾರೆ. ಸೊ ಡೆಫಿನೆಟ್ಲಿ ಐ ಕ್ಯಾನ್ ಕನ್ಸಿಡರ್ 1, 2 and 3, all 3 are correct here. Okay, then moving on to 15th question. 15th question ಅಲ್ಲಿ ನೀವು ಎಕ್ಸ್ ಸಿ ಎಮ್ ಫೈಂಡ್ ಔಟ್ ಮಾಡಿ, ವೈ ಸಿ ಎಮ್ ಫೈಂಡ್ ಔಟ್ ಮಾಡಿ. ಓಕೆ, ಎಕ್ಸ್ ಸಿ ಎಮ್ ವೈ ಸಿ ಎಮ್ಗೆ ಫಾರ್ಮುಲಾ ನಮ್ಗೆ ಗೊತ್ತಿದೆ. ಏನಪ್ಪ ಎಕ್ಸ್ ಸಿ ಎಮ್ ಅಂದರೆ? ಎಕ್ಸ್ ಸಿ ಎಮ್ ಇಸ್ summation of mi xi divided by summation of mi. ಇದು ಎಕ್ಸ್ ಸಿ ಎಮ್. ಅದೇ ರೀತಿ ವೈ ಸಿ ಎಮ್ ಏನಿದೆ? summation of mi yi divided by summation of mi. ಸೊ ಇದರ ಬೇಸಿಸ್ ಮೇಲೆ ನಾವು ಕ್ಯಾಲ್ಕುಲೇಷನ್ ಮಾಡಿಬಿಟ್ರೆ ಆಗುತ್ತೆ. ಯಾಕಂದರೆ ಇಕ್ವಿಲ್ಯಾಟ್ರಲ್ ಟ್ರಯಾಂಗಲ್ ಇದೆ, ಒಂದು ಟ್ರಯಾಂಗಲ್ನ ಡ್ರಾ ಮಾಡಿಕೊಂಡು ಕೋಆರ್ಡಿನೇಟ್ಸ್ನ ಈಸಿಯಾಗಿ ಫೈಂಡ್ ಔಟ್ ಮಾಡ್ಕೋಬೋದು. ಸೊ ಯೂಸಿಂಗ್ ದಿಸ್ ವಿ ಶುಡ್ ಗೆಟ್ ಆಪ್ಷನ್ 7/2, 3√3. ಓಕೆ, ಸೊ ನಮಗೆ 7/2, 7/12, 3√3/12. ಸೊ ಇದು ಆಪ್ಷನ್ 4 ಬರ್ತಾ ಇದೆ ನಮಗೆ. ಓಕೆ, ಫೈನ್. ಸೊ ಇವಾಗ ಮೂವಿಂಗ್ ಆನ್ ಟು 16ನೇ ಕ್ವೆಶ್ಚನ್ಗೆ. 16ನೇ ಕ್ವೆಶ್ಚನಲ್ಲಿ 2 ಫ್ಲೈ ವೀಲ್ದು ಕನ್ಸೆಪ್ಟ್ನ ಕೊಟ್ಟಿದ್ದಾರೆ ಇಲ್ಲಿ. ಓಕೆ, ಸೊ ಇಲ್ಲಿ ನಮ್ಗೇನು ಗೊತ್ತಾ? ಫಸ್ಟ್ ನಾವು ಟಾರ್ಕ್ ಕಂಡುಹಿಡ್ಕೋಬೇಕು. ಟಾರ್ಕ್ನಿಂದ ಆ್ಯಂಗ್ಯುಲರ್ ಎಕ್ಸಲರೇಷನ್ ಟೌ ಇಸ್ ಈಕ್ವಲ್ ಟು, ವಾಟ್ ಇಸ್ ದ ಫಾರ್ಮುಲಾ ದಟ್ ಐ ನೋ? ಐ ಇಂಟು ಅಲ್ಫಾ, ಹೌದಾ? ಓಕೆ, ಸೊ ಟೌ 1 ಈಕ್ವಲ್ ಟು ವಾಟ್? I1 ಇಂಟು ಅಲ್ಫಾ 1 ಅಲ್ವಾ? ಸೊ ಟೌ 1 ಇಸ್ I1 alpha 1. Just a minute. Okay, tau 1 is I1 into alpha 1. ಸೊ ಇದರಿಂದ ನನಗೇನು ಬಂತು? ಇದರಿಂದ ಆಲ್ಫಾ 1 ಸಿಗುತ್ತೆ. ಸೊ ಟೌ 1 ನಮ್ಗೆ ಕೊಟ್ಟಿದ್ದಾರೆ. ಟಾರ್ಕ್ ಎಷ್ಟು ಕೊಟ್ಟಿದ್ದಾರಪ್ಪ? ಟಾರ್ಕ್ ಕೊಟ್ಟಿರೋದು ಈ ಪ್ರಾಬ್ಲಮಲ್ಲಿ ನಮಗೆ 10 ಕೊಟ್ಟಿದ್ದಾರೆ. I1 4 ಇದೆ. ಸೊ ಡೆಫಿನೆಟ್ಲಿ ಐ ಶುಡ್ ಗೆಟ್ ಆಲ್ಫಾ 1 ಈಕ್ವಲ್ ಟು ವಾಟ್? ಆಲ್ಫಾ 1 ಈಕ್ವಲ್ ಟು 5/2 ಬಂತು, ಹೌದಾ? ಅದೇ ರೀತಿಯಲ್ಲಿ ಆಲ್ಫಾ 2 ಕಂಡು ಹಿಡಿಯೋದಕ್ಕೆ ಯು ಜಸ್ಟ್ ಮೇಕ್ ಯೂಸ್ ಆಫ್ ಎ ಇಸ್ ಈಕ್ವಲ್ ಟು ಆರ್ ಇಂಟು ಆಲ್ಫಾ. ಸೊ ಇಲ್ಲಿ ಪ್ಯೂರ್ ರೊಟೇಷನ್ ಇರೋದ್ರಿಂದ ಎ ಈಸ್ ಕಾನ್ಸ್ಟಂಟ್. ಸೊ ಹೀಗಾಗಿ R1 alpha 1 ಈಕ್ವಲ್ ಟು R2 alpha 2. ಈ ಫಾರ್ಮುಲಾ ಯೂಸ್ ಮಾಡಬೇಕು. ಇದನ್ನು ಯೂಸ್ ಮಾಡಿಬಿಟ್ಟು ಯು ಕ್ಯಾನ್ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಆಲ್ಫಾ 2. ಸೊ ಆಲ್ಫಾ 2 ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಿದವಾಗ ನನಗೆ ಆಲ್ಫಾ 2 ಎಷ್ಟು ಬರ್ತಾ ಇದೆ? ಇಲ್ಲಿ 5/3 ಬರ್ತಾ ಇದೆ. ಓಕೆ, ದೆನ್ ಈ ಆಲ್ಫಾ ಟು ಬಂದ ಮೇಲೆ ಟಾರ್ಕ್ ಸೆಕೆಂಡ್ ಟಾರ್ಕ್ನ ಈಸಿಯಾಗಿ ಕಂಡುಹಿಡ್ಬೋದು. ಟೌ ಟು ಇಸ್ ಈಕ್ವಲ್ ಟು ವಾಟ್ I2 ಇಂಟು ಆಲ್ಫಾ ಟು. ಅಷ್ಟೇ, ಮುಗಿದೋಯ್ತು. ಸೊ ಇವಾಗ ನಮಗಿಲ್ಲಿ ಕ್ಲಿಯರ್ ಆಗಿ ಗೊತ್ತಾಗೋದೇನು, ಆ್ಯಂಗ್ಯುಲರ್ ಎಕ್ಸಲರೇಷನ್ ಆಫ್ ಸ್ಮಾಲರ್ ವೀಲ್ 5/2 ಅಂದರೆ A3, ಆಮೇಲೆ C1 B2. ಸೊ ಯಾವುದಿದೆ ನೋಡಿ A3, ಅದೇ ಆಪ್ಷನ್ನ ನಾವು ಪಿಕ್ ಮಾಡ್ಕೊಬಿಡೋಣ. ಸೊ ಆಬ್ವಿಯಸ್ಲಿ ಇಟ್ ಶುಡ್ ಬಿ A3 B2 A3 B2 C1. ಸೊ ಮೂರನೇ ಆಪ್ಷನಲ್ಲಿದೆ. ಓಕೆ, ದೆನ್ 17ನೇ ಕ್ವೆಶನಲ್ಲಿ ಇವಾಗ ಇದರಲ್ಲಿ ಡೈರೆಕ್ಟ್ ಆಗಿರೋವಂಥ ಕ್ವೆಶನ್ ಇದು. ಸೊ ಇದರಲ್ಲಿ ನಮ್ಗೆ ಗೊತ್ತಿದೆ, ಒಂದು ಸೂರ್ಯ ಒಂದು ಇದರಲ್ಲಿ ತನ್ನ ಕಕ್ಷೆಯಲ್ಲಿ ಸುತ್ತುವಾಗ ಅವನು ಅಲ್ಲಿ ಆ್ಯಪ್ ಹೀಲಿಯಾನ್ ಪೆರಿಹೀಲಿಯಾನ್ 2 ಪಾಯಿಂಟ್ಸ್ಗಳು ಬರ್ತಾ ಇದ್ದಾವೆ. ಸೊ ಅದರ ಪ್ರಕಾರ ಹೋದರೆ ನಮಗೆ ಸೆಕೆಂಡ್ ಆಪ್ಷನ್ ಕರೆಕ್ಟಾಗಿ ಬರುತ್ತಿಲ್ಲ ಮಕ್ಕಳೇ. ಓಕೆ, 18ನೇ ಕ್ವೆಶನಲ್ಲಿ ಇಲ್ಲಿ ಟೋಟಲ್ ಎನರ್ಜಿ ಆಫ್ ಸ್ಯಾಟಲೈಟ್ ಮೇಲೆ ಕ್ವೆಶನ್ ಇದೆ. ಸೊ ಇಲ್ಲಿ ನಮ್ಗೆ ಫಾರ್ಮುಲಾ ಗೊತ್ತಿದೆ, ಏನಪ್ಪ, ಟೋಟಲ್ ಎನರ್ಜಿ E ಇಸ್ ಈಕ್ವಲ್ ಟು ಮೈನಸ್ G m1 m2 ಡಿವೈಡೆಡ್ ಬೈ 2 ಇಂಟು R ಪ್ಲಸ್ H. ಇದು ಫಾರ್ಮುಲಾ ಅಲ್ವಾ. ಸೊ ಇದರ ಪ್ರಕಾರ ಹೋದರೆ ವಿ ವಿಲ್ ಗೆಟ್ ಆಪ್ಷನ್ 4 ಆಸ್ ಅವರ್ ರೈಟ್ ಚಾಯ್ಸ್ ಇನ್ ದಿಸ್ ಕೇಸ್. ಓಕೆ, ದೆನ್ ಮೂವಿಂಗ್ ಆನ್ ಟು ನೆಕ್ಸ್ಟ್ ಕ್ವೆಶನ್. ಇವಾಗ 19ನೇ ಕ್ವೆಶನಲ್ಲಿ 19th ಕ್ವೆಶನ್ ಏನಿದೆಪ್ಪ, 2 ವೈರ್ಗಳಿದ್ದಾವೆ. ಓಕೆ, ಸೊ ಈ 2 ವೈರ್ಗಳ ಮಧ್ಯದಲ್ಲಿರುವಂಥ ಇನ್ಕ್ರೀಸ್ ಇನ್ ಲೆಂತ್ ರೇಷಿಯೋ ಕೇಳಿದ್ದಾರೆ. ಸೊ ಇದು ಈ ಪ್ರಶ್ನೆಗಿದೆಯಲ್ಲ, ನೀವೇನು ಮಾಡಿ, ಜಸ್ಟ್ ಫಾಲೋ ದಿಸ್ ಅಪ್ರೋಚ್. ಡೆಲ್ಟಾ L ಈಸ್ ಈಕ್ವಲ್ ಟು FL ಬೈ AY. ಈ ಫಾರ್ಮುಲಾ ಇದೆ ನನಗೆ, ಹೌದಾ. ಸೊ ಇದರಿಂದ ನನಗೇನು ಗೊತ್ತಾಗುತ್ತೆ, ಡೆಲ್ಟಾ L ಪ್ರಪೋರ್ಷನೇಟ್ ಟು L ಬೈ ಏರಿಯಾ. ಏರಿಯಾ ಅಂದರೆ ಏನಪ್ಪ, ಸ್ಕ್ವೇರ್ ಆಫ್ ರೇಡಿಯಸ್. ಓಕೆ, ಸೊ ಡೈರೆಕ್ಟ್ಲಿ ಯು ಜಸ್ಟ್ ಮೇಕ್ ಯೂಸ್ ಆಫ್ ದಿಸ್ ಪ್ರಪೋರ್ಷನಾಲಿಟಿ ಕಾನ್ಸೆಪ್ಟ್. ಅದರಿಂದ ನಿಮ್ಗೆ ಈಸಿಯಾಗಿ ಗೊತ್ತಾಗ್ಬಿಡುತ್ತೆ. ಓಕೆ, ಸೊ ಹೆನ್ಸ್ ಆನ್ಸರ್ ವಾಟ್ ವಿ ಗೆಟ್ ಹಿಯರ್ 4:3 ಬರ್ತಾ ಇದೆ. ಓಕೆ, ನೆಕ್ಸ್ಟ್ 20th ಕ್ವೆಶನಲ್ಲಿ ಇದು ಬರ್ನಾಲಿಸ್ ಪ್ರಿನ್ಸಿಪಲ್ ಮತ್ತು ಕಂಟಿನ್ಯೂಟಿ ಪ್ರಿನ್ಸಿಪಲ್ ಬೇಸ್ಡ್ ಕ್ವೆಶನ್. ಓಕೆ, ಇದರಲ್ಲಿ ನೀವೇನು ಮಾಡಬೇಕು, ಫಸ್ಟು ಯು ಶುಡ್ ಗೋ ಅಹೆಡ್ ಆ್ಯಂಡ್ ಕ್ಯಾಲ್ಕುಲೇಟ್ ವೆಲಾಸಿಟಿ ಫಸ್ಟ್. ಸೊ A1 V1 ಈಕ್ವಲ್ ಟು A2 V2. ಈ ಫಾರ್ಮುಲಾನಿಂದ ಇದು ಯಾವುದಪ್ಪ, ದಿಸ್ ಇಸ್ ಕಂಟಿನ್ಯೂಟಿ ಪ್ರಿನ್ಸಿಪಲ್. ಇದನ್ನು ಯೂಸ್ ಮಾಡಿಕೊಂಡು V2 ಕಂಡು ಹಿಡಿಯೋಣ ಫಸ್ಟ್. ಓಕೆ, V2 ಕಂಡು ಹಿಡ್ದಾದ್ಮೇಲೆ V2 ನನಗೆ ಎಷ್ಟು ಬರ್ತಾ ಇದೆ, ಇಲ್ಲಿ 2 ಮೀಟರ್ ಪರ್ ಸೆಕೆಂಡ್ ಬರ್ತಾ ಇದೆ. ಯಾಕೆಂದರೆ V1 1 ಕೊಟ್ಟಿದ್ದಾರೆ. ಸೊ ನೆಕ್ಸ್ಟ್ ಏನು ಮಾಡಿ, ಬರ್ನಾಲಿಸ್ ಪ್ರಿನ್ಸಿಪಲ್ ಅಪ್ಲೈ ಮಾಡಿ. ಸೊ P1 ಪ್ಲಸ್ ಹಾಫ್ ರೋ V1 ಸ್ಕ್ವೇರ್ ಇಸ್ ಈಕ್ವಲ್ ಟು P2 ಪ್ಲಸ್ ಹಾಫ್ ರೋ V2 ಸ್ಕ್ವೇರ್. ಇಲ್ಲಿ ನೋಡಿ, ರೋ GH ಬರೋದಿಲ್ಲ, ಪೊಟೆನ್ಷಿಯಲ್ ಎನರ್ಜಿ 0, ಚೇಂಜ್ ಇನ್ ಪೊಟೆನ್ಷಿಯಲ್ ಎನರ್ಜಿ 0 ಇರೋದ್ರಿಂದ ಇಲ್ಲಿ ಕ್ಯಾನ್ಸಲ್ ಆಗಿದೆ. ಸೊ ಇದನ್ನು ಅಪ್ಲೈ ಮಾಡಿದ್ರೆ ನನಗೆ ಪ್ರೆಷರ್ P2 ಸಿಗ್ತಾ ಇದೆ. P2 ಇಸ್ ಈಕ್ವಲ್ ಟು ಹೌ ಮಚ್, P2 ನನಗೆ 500 ಪಾಸ್ಕಲ್ ಬರ್ತಾ ಇದೆ. ಓಕೆ, ಸೊ ದಿಸ್ ಇಸ್ ಸೊಲ್ಯೂಷನ್ ಫಾರ್ 21. ಓಕೆ, ಸೊ ಇದು 20th ಕ್ವೆಶನ್. ಐ ಆಮ್ ಸಾರಿ, ಕ್ವೆಶನ್ ನಂಬರ್ 20. ಓಕೆ, ಇವಾಗ ಮಕ್ಕಳೇ 21ನೇ ಕ್ವೆಶನ್ನಿಂದ ಮುಂದಿನ ಪ್ರಕ್ರಿಯೆಯನ್ನು ನನ್ನ ಕಲೀಗಾದಂಥ ಮಿಸ್ಟರ್ ನಾಗರಾಜ್ ದುರ್ಗಣ್ಣ ಅವ್ರ ಸರ್ಗೆ ನಾನು ಇನ್ವೈಟ್ ಮಾಡ್ತಾ ಇದ್ದೀನಿ. ಸೊ ವೆಲ್ಕಮ್ ಸರ್, ವೆಲ್ಕಮ್.
Hello dear students, welcome. So I'll start from the question number 20 question number ಇಂದ ಸ್ಟಾರ್ಟ್ ಮಾಡೋಣ. ಸೊ 21st question, sorry 20 ಅಲ್ಲ 21st question ಇಂದ ಸ್ಟಾರ್ಟ್ ಮಾಡೋಣ. ಸೊ question number 21, so which is based on okay, so here it is based on heat flow. Okay, so mechanical properties of heat ಅನ್ನೋ ಚಾಪ್ಟರ್ ಮೇಲೆ ಬರುತ್ತೆ. ಸೊ ಇಲ್ಲಿ 3 ಮೆಟಲ್ ರಾಡ್ಸ್ ಆಫ್ ಸೇಮ್ ಮಟೀರಿಯಲ್, ಐಡೆಂಟಿಕಲ್ ಮಟೀರಿಯಲ್ ಇರೋದ್ರಿಂದ ಅದರ ರೆಸಿಸ್ಟೆನ್ಸ್ ಎಲ್ಲಾನು ಸೇಮ್ ಇರುತ್ತೆ. ದಟ್ ಇಸ್ ಫಸ್ಟ್ ಪಾಯಿಂಟ್. ಸೇಮ್ ಮಟೀರಿಯಲ್ and identical in all respects to join as shown in the figure. Identical ಅಂದ್ರೆ their length, radius ಆಗಿರಬಹುದು, diameter ಆಗಿರಬಹುದು, whatever it might be. So yes, next. So here it is based on the heat flow. Okay, so ಇಲ್ಲಿ ನೀವೊಂದು ಡಯಾಗ್ರಾಮ್ ಹಾಕಬಹುದು. ನಾವಿಲ್ಲಿ ಸೊ heat flow ಹೇಗೆ ಬರುತ್ತೆ ಇಲ್ಲ ಅಂದ್ರೆ, so heat always flow from higher temperature to lower temperature. ಸೊ ಇಲ್ಲಿಂದ ಈ ಕಡೆ ಬರುತ್ತೆ. ಅದೇ ರೀತಿ ಈ ವೈರ್ಗೂ ಕೂಡ ಟೆಂಪರೇಚರ್ 90 ಡಿಗ್ರಿ ಸೆಲ್ಸಿಯಸ್ ಟು ಎಕ್ಸ್ ಗೆ ಬರುತ್ತೆ. ದೆನ್ ಹಿಯರ್ ಇಟ್ ಫ್ಲೋಸ್ ಫ್ರಮ್ ಎಕ್ಸ್ ಟು 0 ಡಿಗ್ರಿ ಸೆಲ್ಸಿಯಸ್ ಬಿಕಾಸ್ ದ heat always flow from higher temperature to lower temperature. Based on that, now this one I will consider as a Q1 and I will consider as a Q2, and this one is considered as a Q3. Then this Q3 must be equal to Q1 plus Q2. So based on this, if you write the difference, a temperature difference bardre, so you can see that 90 minus x divided by r plus 90 minus x divided by r. So ಎರಡು ಕಡೆ ಸೇಮ್ ಇದೆ, 90 ಈ ಕಡೆನೂ 90 ಇದೆ. So at x point, ಇದನ್ನ we can assume like a Kirchhoff's current law. So ಅದರ ಪ್ರಕಾರ ನಾವು ಆಡ್ ಮಾಡಬಹುದು ಇದನ್ನ. Then this is equal to 0 minus x, sorry, x minus 0 ಬರಬೇಕು. So it is x minus 0 divided by r. In all the three cases r will get cancelled. So ಅದನ್ನ ನಾವು ಸಾಲ್ವ್ ಮಾಡಿದ್ರೆ, if we solve that, so which is x by r, or x equal to 90 plus 90, 180 and minus 2x ಈ ರೀತಿ ಬರುತ್ತೆ. ಸೊ minus 2x ಈ ಕಡೆ ಬಂದ್ರೆ 3x ಬರುತ್ತೆ, which is equal to 180. So x is equal to 3 ones are 3 6 are, so it will be 60 ಬರುತ್ತೆ. So 60 degree Celsius is your answer. The answer ಏನಪ್ಪಾ ಅಂತಂದ್ರೆ 60 degree Celsius. Okay, we'll move to the next question. That is question number 22. If you read the question number, a gas is taken from state A to state B, two different paths. We can draw. So this is question number 21. Now question number 22. So you can draw that concept like this. This is a point A. It is point B. Now you are moving from the point A to point B in two different situations or two different paths, 1 and 2. Right? Work done by the system along these two paths are Q1, Q2 and W1, W2. Here we know the first law of thermodynamics, that is total heat supplied to the system is equal to work done plus change in internal energy. Correct? So next, so here initial point and final point are same, therefore the internal energy for first one is equal to internal energy for second one. Therefore if you write that, what is internal energy here, so that is Q minus work done. So based on this we can write Q1 minus W1 must be equal to Q2 minus W2. So the answer is yes. So that is 1. Now question number 23. If you observe, at a 27 degree Celsius temperature, the mean kinetic energy of atoms of an ideal gas is even. If the temperature is increased to 327 degree Celsius, then the mean kinetic energy of the atoms will be. So we'll see that question now. Okay guys, we'll see the question number 23. So in question number 23, first you write down temperature T1, which is equal to 27 degree Celsius, convert it into Kelvin, plus 273, which is 300 Kelvin. Similarly you can calculate T2, which is 327 degree plus 273, you get 600 Kelvin. And we know that average kinetic energy, the formula for average kinetic energy of atoms K1 is equal to 3 by 2. So this is Boltzmann constant K into T1. So if you apply the formula, so that is 3 by 2 K as Boltzmann constant, T1 temperature is 300. Yes. Next, similarly K2, 3 by 2 K T2 is equal to 3 by 2 K. So you know what is temperature T2 is 600. Yes, very good. 600 Kelvin. Now this is I will call this one energy as E1 and this one I will call energy as E2. Now if you divide them, dividing these two, E2 by E1, then you will get, after cancelling, is equal to 2. Therefore E2 is equal to 2 times of E1. So this is the answer. So answer is second option. Yes. Now we can move to the next question. 24th, which is based on the oscillation chapter. So it is the energy diagram, total energy, potential energy and the kinetic energy. At one position, the potential energy equal to kinetic energy and total energy is conserved. That point is this point. So that point is the amplitude of A by root 2. So the option is directly we can say that is A option. 24, A option. Now 25, the angle between the particle velocity and wave velocity. Let us understand this diagram so you can easily answer that. So this is a transverse wave in which the particle moving upward and downward. So this is a velocity of the particle and the wave is moving perpendicular to the vibration of the particle. This is wave velocity. Then what is the angle of between these two? Yes, you only can say that, yes, 90 degree. The answer is 90 degree is nothing but pi by 2 radian. That is first option. Now come to the question number, this is question number 25. Next question, question number 26. If you read the question properly, you can understand that a metallic sphere of radius capital R, a charge small q kept certain distance from the another metallic sphere of radius R by 4 carrying a charge capital Q. What is the electric flux at any point inside the metallic sphere of radius R due to the sphere of radius R by 4? Now you can say that, so here charges are there. So these charges can produce electric field which are entering into the capital R and they are leaving the surface of the capital R. But no electric field line is going through inside the radius R. So the flux is 0. So what is electric flux? Flux is, electric flux formula is what? EA cos theta. Here there is no charge which is moving inside this closed surface. So it is, so if we want to find out the flux, there must be closed surface. So here there is no closed surface, hence the flux is 0. Okay, we'll move to the next question. Yes. So 27 question. Okay. So you are given a dipole of charge plus q and minus q separated by a distance of 2r. A sphere A radius of r and passes through the center of dipole as shown in the figure below, and another sphere of capital B of radius 2r. Now you can observe here. So this is the one surface and this is another surface. So here he is asking electric flux through the sphere A only, not through the whole dipole. If suppose he asks whole dipole, definitely it should be 0. Why? Because due to negative charge it is downward, due to positive charge it is upward. So the net charge will be 0, therefore flux will be 0. But it is not like that. They are asking through only sphere A. Clearly sphere A only they are asking. Because of that reason, in this closed surface, how much charge is there? Yes, minus q. So we know that flux is equals to, according to Gauss law, total flux is equal to 1 by epsilon naught times the net charge. Here the net charge is minus q. That's why the option will be minus q upon epsilon naught. So this is the answer. Now we'll move to the next question. This is the question number 27. Next question 28. If you observe question number 28, so here it is given from the electrostatic potential chapter, second chapter. So here there is a one electric field line on, there are 2 points, first point A and another point B. At first point VA potential is minus 3 volt and VB is 5 volt. Now here they are asking the charge will move from, what is the charge value? So here the charge is 5 millicoulomb, that is moving from B to A, that is moving from B to A. So that work done is given by potential difference, that I can write it as VA minus VB into charge Q. So if you substitute the values, you will get it as VA is minus 3 minus of 5 into charge value is 5 into 10 to the power of minus 3 coulomb, then you are going to get minus 0.04 joules as an answer. So this is the work done. Okay guys? Yes. Next we'll move to the 29th question. If you read the question number 29, it is from the first chapter. So here charges uniformly spread over the surface of the conductor. So I will draw here one surface of the conductor. Now here inside electric field is 0. Why electric field is 0? Because charge is 0. If charge is 0, there is no flux, no electric field, and at the surface is maximum, and outside the surface is electric field E is equal to inversely proportional to 1 by r square. You can say like that. So that's why it is fourth option is correct. Okay? Yes. Next question, question number 30, which is based on the first electric field chapter, first chapter. So in that we have a torque, second chapter, electrostatic potential. In that potential energy of a dipole, and we know the formula for that. What is the potential energy of a dipole? Potential energy equal to minus PE cos theta. Now you start substituting these values, you will get the answer. Now first you substitute 180, cos 180 is minus 1, so minus of minus plus, so cos for 180 the answer is P. For 120, cos 120 is minus 1 by 2, so hence it will be 1 by 2 times of P. For cos 90 is 0, 0 into anything is 0, therefore answer this one. So you can choose the answer now. What is the answer? Yes, that is third option. Now we'll move to the next question, 31st, which is based on statement. Which of the following statement is not true? So many times we will not give the concentration for not true or true. Okay. So here they are asking which one is not true. So after reading all the questions, you will get that work done to move a charge on an equipotential surface is not 0. On an equipotential surface it is 0, but here he is giving not 0. That's why not correct statement is fourth one. Okay. Next, which of the following is correct statement for 32 question? So here if you observe the if you go through the NCERT syllabus, new NCERT syllabus, in that, so the answer is Gauss law does not hold good for charge situated outside the Gaussian surface, or Gauss law is true for any closed surface. So the option is Gauss law is true for any closed surface is the correct option. Gauss law is true for any closed surface. This is a correct answer. Now next, question number 33. So you can observe that question number 33, which is from current electricity. In the following circuit, terminal voltage across the cell So what is the terminal voltage across this cell they are asking. To calculate terminal cell, first we need a total current, that is I want. How you will calculate that net current? Total current is equal to total potential divided by total resistance. So here current I is equal to total EMF is E divided by total external resistance plus internal resistance R. This formula you have to use. If you use that, you will get answer as 0.5 volt. Sorry, 0.5 ampere. So this 0.5 ampere you can use to calculate the potential difference across point A and point B. So that is potential across VAB is equal to total EMF E minus current through the circuit into internal resistance R. If you solve this one by putting the values, you will get 1.95 volt. So this is the answer. Okay, so that is first option. Now 34th question, you can see here two cells are there, EMF E1 and EMF E2, their internal resistance R1 and R2. Here they have given E2 is greater than E1 and R2 is greater than R1. So in parallel combination, basically the potential difference must be equal, but here they have given E1 and E2 are two different values. Then where the resultant will come? That resultant will be lies between E1 and E2. So here E equivalent is greater than E2, which is wrong. E equivalent is less than E1, that is also wrong. That E equivalent will come in between E1 and E2, but it comes near the smaller resistance value. So out of this R1 and R2, which one is smaller? R1. So that's why the answer we have to pick is third question. So here equivalent EMF comes in between E1 and E2, but the values lies more towards E1 because R1 is less. That is the reason why we have to choose the correct answer as 3. Okay, we'll move to the next question. 35. So this one is there in your NCERT textbook. The resistivity, whenever we are studying Ohm's law, at that time the variation of the resistance with respect to temperature, all the concepts will be there. So based on that, here resistivity, how it varies temperature, 3 different graph you can see over there. Correct? The first one is 35 question. So here they have given first X. X is what there? What is the graph for X? The graph would be like this. And this is for copper. So here they have given along x-axis as a temperature, along y-axis as a resistivity. Correct? Then for conductor, nichrome. For nichrome, it is a straight line. You can go through the NCERT textbook, it was there. It is there, right? Now next for third one, definitely it is for semiconductor. As temperature increases, its resistivity decreases. So this is for semiconductors. This is for nichrome and this is for semiconductor. So this is question number 35. Now question number 36. So current carrying wire of non-uniform cross section. Suppose, so this is 36 question number. So this is non-uniform cross sectional wire. You can say here two different areas, A1, A2, two different areas. This is non-uniform cross section areas. So where the current is always constant. So here current is always constant, not the drift velocity. So we can say that the current is constant throughout the wire. Okay. So answer here only current, not drift velocity. Drift velocity again changes. Okay. Now question number 37. So question number 37, if you observe, okay. So here it depends on, the graph depends on resistivity. So what is the formula for resistivity? Resistivity is equal to resistance R into A by L. correct? So they are taking other parameters like length and temperature constant, the graph variation between resistance of the wire and function of its diameter. So function of diameter, so resistance inversely proportional to area. From this formula you can say resistance is inversely proportional to area. So you can write resistance is inversely proportional to diameter, square of the diameter. So when it is square of the diameter, you can observe that it is parabolic and it is decreasing, hence option is 2. Second option is correct. Okay, next. Now next 38th question. We'll see 38th question. So here two parallel current carrying conductors are there. Here current I1 will flow, here current I2 will flow. So you have derived this equation when the two currents, two current carrying conductors, if the direction of current is same, both of them they will attract. This is force F1, force F2. They will attract. With the formula, that magnetic force is equal to mu naught. If both are carrying same current, it is I square upon 2 pi r. So the option is fourth option. Now question number 39. So for question number 39, if you read the question, it is based on the solenoid. So here length of the solenoid is 1 meter and diameter as 4 centimeter. It has 5 layers that I will take n as a 5 layers, capital N, where small n is 1000. We can write it as a 10 raised to 3. So current I is 7 ampere. Now they are asking magnetic field at the center of the solenoid. The magnetic field at the center of the solenoid is equal to mu naught into n into I with how many layers, that is capital N. So if you substitute all these values, you will get 4.396 into 10 to the power of minus 2 Tesla. So this much of value you will get, you can check it out. So the answer is first option. And 40th question, two similar galvanometers are converted into an ammeter and milliammeter. First one is converted as a ammeter and second one is milliammeter. Just observe that ammeter will measure more current, milliammeter will measure less current. To measure the less current, resistance should be high. For a more current, resistance should be less. Only based on the statement you can judge that the answer for the ammeter as compared to the resistance milliammeter will be less. Or if you want to take the formula for that, you can take S is equal to, which is resistance of the ammeter, which is equal to Ig into capital G upon I minus Ig. So here Ig will be negligible, you can check that for ammeter and milliammeter. So the simple technique is, for milliammeter less current, resistance will be more. For ammeter, more the current, lesser will be the resistance. So simple. So thank you for watching. Now I will hand over the discussion, further discussion to my colleague, Mr. Anand sir. Please welcome sir.
Okay, so now we'll continue the discussion. So we'll start from the question number 41. Okay, so look at, so here it is a concept based question, so it's a very straightforward question. So which of the following statement is true in respect of diamagnetic substances? So just look at the 4 statements here. Okay, first statement is permeability is greater than 1000, that is only for a ferromagnetic materials. Then susceptibility decreases with the temperature. Susceptibility decreases with the temperature, that is applicable only for a paramagnetic materials. And the third one is susceptibility is small and negative. Small and negative is possible only for the case of the diamagnetic, and they are feebly attracted by the magnets. Okay, that is completely different. So the third one is the right option for a question number 41. Okay, so now we'll look at into the next 42. So it is also a concept based question. So just look at, so identify the correct statement. Again we have to look at all the statements here. So but the first statement itself we get the the right statement here. So that is, a straight current carrying conductor has a circular magnetic field lines around it. Okay, circular magnetic field lines around it. So that is actually the correct statement. So what we know already here is, whenever we have a straight conductor carrying current, whenever we have a straight conductor carrying current, so magnetic field lines are concentric, and hence we can easily say that the first statement is correct. But still we'll also look at, so why the other three statements are wrong. So that is also important. That is, the second statement is, direction of magnetic field due to current element is given by Fleming's left hand rule. So Fleming's left hand rule gives only the direction of the magnetic force acting on a current carrying conductor. So that is not for a case of the Biot-Savart's law. Next one is, magnetic field inside a solenoid is non-uniform is given. So but is actually it is a uniform. Fourth one is, current carrying conductor produces electric field around it. So current carrying conductor, so it produces only the magnetic field because the net free charges present inside the conductor, so that becomes 0, and as a result Q enclosed is 0. If the Q enclosed is 0, so we can say that the total electric field will be 0. So therefore that is the option 1 is the right answer here. So now we'll look at into the next question number, that is the 43 here. For a question number 43, it is a very simple graph based question. Here we have a infinitely long straight conductor carrying current, and we have to look at what is the variation of the magnetic field with respect to the distance. So what's the equation for this particular one? So B equals to mu naught I divided by the 2 pi r. So therefore it is inversely proportional to the r, and so straight away we can give the answer here, that is option 1 is the right answer. So next, question number 44. So here, so it is slightly a tricky kind of a question. So look at here, that is, electron and photon have the same de Broglie wavelength. So then we'll have same, which quantity will be the same. So what is the equation? We know it for a de Broglie wavelength. So that is, so lambda equals to h by p. So now if we are writing for an electron, so this p equal, so p and that is for an electron also. And next what we have a photon. Photon, for a photon, how do you write the equation for lambda? So that is using the equation of the photon. So that is E equals to, we know that E equals to hc by lambda. So using this particular one, we can write as lambda equals to hc divided by the E. And we also know that energy we can also write in terms of the momentum. So that is E equals to P into the C. And as a result, if we just substitute here, as a result, if you just substitute, so E is equals to PC, CC will get cancelled. So lambda of the photon, so we can write it as that is h divided by the momentum of the photon. And compare these two equations. And when you compare these two equations, what is given condition here? The given condition is wavelength is the same. If the wavelength is the same, what else will also be the same here? That is, the momentum of the electron and the photon becomes same here. Is this one clear? So that is option 3 is the right answer. I hope it is clear. So now we'll look at into the next question, that is the 45. So that is, here is a question based on a photocell, and what is given here is, if the frequency is increased, what happens to the current in that particular photocell. So what we know, so we can have to apply the concepts whatever we have learnt in the dual nature chapter. If the frequency changes, so it does not increase or decrease the intensity. So we know that photoelectric current is directly proportional to the intensity but not the frequency. And what is given in this particular case, frequency is changed. They have not told anything about the intensity. It implies that it is a constant. So therefore what we can choose, so that is a fourth graph, so that will be the right answer. It is a constant with respect to that. So next one. So next question is based on a chapter EMI, electromagnetic induction. So what is the question here? So bar magnet is pushed towards the coil. If the bar magnet is pushed towards the coil, So then, so they have given that it shows the deflection towards the x. Deflection is towards the x here. And next thing is, okay, when this magnet is pulled away from the coil, so that is moving in a opposite direction. So galvanometer, okay, deflection will be in a opposite way. So as a result, so what we can say, so therefore it is deflecting towards the x dash. So it's a very simple concept based question. Okay, so we'll go to the next one, that is the question number 47. That is, so here we have a magnetic field is given, and we have a square, okay, loop of side 2 meter that is kept in a YZ plane. Okay, the one important point you have to remember here is, if the loop is placed in a YZ plane, so direction is along the x axis. So if that is the case, and what actually we have to find out, that is the magnetic flux. We have to find out what's the equation for the magnetic flux. So that is a dot product of magnetic field with the area. So area is along which direction? Area is along the x axis. If it is x axis, we have to look at only the components of the x axis. So here we have the phi. Okay, area is, okay, the side is given. So 2 into 2, that is a 4. So therefore, okay, 20 Weber will be the right answer. So that is the option 4. Okay, so now we'll look at into the next. Okay, it is also a very straightforward, easy question. In a domestic electric main supply, the voltage and current are always they are, okay, they are AC, they are not the DC here. So therefore AC voltage, AC current. So that is the correct answer. Okay, so now, okay, now we'll move on to the next one. A sinusoidal voltage produced by an AC generator at any instant is given by equation RMS value of the voltage and frequency. So in this particular equation, what is this value represent? 311. 311 represents the V0. Okay, what is the equation for the VRMS? So VRMS is V0 divided by the, okay, root 2. So if that is the case, 311 divided by root 2, 1.414. So that is very near to 220. Okay, and next we have to find the frequency. For a frequency, we have to look at, so what is the general equation? You have to remember, V equals to V0 sine omega t. So, okay, compare this omega with the 314. If omega is 314, what is the omega here? 2 pi into f. So that is equals to 100. So what will be the f then? So f will be, so it is just the 50 hertz. Okay, you can do the simple. So it is not, sorry, it is not 100 actually. Sorry, it is 314. So 314, so f will be 50 hertz. Okay, so which one is the right option then? So that is a 220 volt, 50 hertz is the right option. Okay, so we'll move on to the next one, that is question number 50. So here it is based on a AC chapter, that is LCR series circuit. Okay, what is given here? So we just try to look at quickly. So here we have a, okay, power supply of 100 volt. Okay, and so what we have, that is the capacitive and also the inductive reactance is given. So that is 24 and 16. Okay, and if the resistance R ohm is connected in series, then potential difference across the combination of the inductor and the capacitor. So okay, so that we have to look at. In that particular case, we'll be writing the, straight away we'll write the equation, that is voltage across the LC. We can write it as, so that is, okay, that is, we can just write it as VL, actually VL minus VC. Okay, we can also extend this, so that is I multiplied by XL minus XC. So first we have to find the I. We know already the value of the XL and the XC. Okay, if you just find the I, we can just substitute and we'll get the answer. So for this, what is the general equation? How to find the I? We know the total potential. Okay, we are applying, that is 100 volt. Okay, and we have to find the current, so that will be I divided by the Z. Z will be the total impedance. So what is the equation for the Z? So I'll just write here. So Z equals to, okay, root of XL minus XC square, okay, plus R square. Okay, so I will not do the substitution part, so that you do it. Okay, I'll just explain here. XL minus XC will be what? XL minus XC will be 8 value, 8 square will be 64, R is 6, okay, 6 square will be 36, 36 plus, okay, 64 will be 100, so square root of that, so that will be, okay, 10. So Z value is 10. Okay, then we have to find the I here. What is the equation for the I? I equals to V divided by the Z. So V is given as 100, 100 by 10. So I will be straight away substitute. So that is 10. So what is XL minus XC? Okay, XL is 24, okay, XC is 16, so therefore it is 8, so 8 into 10, so that will be 80. So that is our option, okay, that is the option 4 is the right answer. Okay, so we'll go on to the next one, that is question number 51. So it is a typical board level question. Okay, look at microwave, the wavelength range is, so that is 0.1 meter to 1 millimeter, okay, visible, okay, that is 700 nanometer to 400 nanometer, ultraviolet, so ultraviolet is 400 nanometer to 1 nanometer, and X-ray, so X-ray is 1 nanometer to 10 power minus 3 nanometer. So therefore, which is that right answer here? So that is the option 4 is the right answer. Okay, so we'll go to the next one. So that is question number 52. So here, light is traveling. Okay, light passes from vacuum to a one refractive index of n. Okay, if the angle of incidence is twice the angle of refraction, so we just note this. So I equals to twice the r. If I equals to twice the r, so then then the angle of incidence in terms of refractive index is, we have to find out. Okay, so we can use that Snell's law equation. What is that? Okay, sin I divided by the sin r, okay, that is equals to n. Okay, we can use this particular one. So first we'll substitute I equals to 2r. If it is I equals to 2r, what do you get? So that is sin 2r divided by the sin r. We'll expand the sin 2r. So that is 2 sin r, okay, into cos r divided by the sin r. So this sin r will get cancelled. Okay, so we get r equals to r equals to, that is a cos inverse of n divided by the 2. So what is asked here? That is the angle of incidence is asked. So what we know here already, I equals to 2r. So therefore, I will be 2 times the r. So therefore, that is the option 1, 2 into cos inverse of n by 2. So that is the right answer. Okay, so then the next question, that is the 53. So what is this particular one? So here we have a convex lens. It is divided into the 3 parts here, and what is asked here is what happens to the power. So actually this particular question, so keep that this particular question is a grace. Okay, and here what is asked here is choose the incorrect option for the reported lens. So what is given? So but actually if we just look at this, we'll just first analyze this particular one and then we'll conclude this particular one. So whenever we have a power, what's the equation for the power? So generally we write P equals to 1 upon the frequency, 1 upon the focal length, and focal length. So we write an equation for a focal length using the lens maker's formula, that is 1 by f equals to n minus 1, 1 by r1 minus 1 by r2. That means what? Focal length basically depends on what? Focal length basically depends on the radius of curvature. Okay, so for this particular part, whenever we divide along this particular direction, so both these two parts have the same focal length. Focal length remains the same, but intensity that will be reduced. Intensity reduced sustainably. So if that is the why focal length remains the same? Because the curvature, whatever we have, so curvature is the same. So therefore, so for this particular one, so power will be the same. Okay, and next what we have, so for this particular one, that is L2 and L3, if you divide along this particular direction, if we have a biconvex lens, that becomes equiplano-convex lens. So for that particular one, we know that focal length reduces to 1 by 2. Focal length becomes f by 2. If focal length becomes f by 2, so what happens to its power? So power becomes twice the P. So for L2 and L3 power increases, and for L1 actually power remains the same. And what is asked here is, so that is you have to look at carefully, that is the incorrect option. That is not the correct option is asked, it is incorrect option is asked. If it is if the question is correct option, so then option 2 actually the right answer. Because it is asked the incorrect option, just look at the option 1, 3 and the 4. All options are wrong. Say for the power of L3, so L3 is 2P, we have got, it is P by 2, and power of L1 is P, but we have here it is P by 2, and power of L2 is actually it is 2P, but here we have the P by 2. So therefore, that is the option. So it is actually, it is a grace. So now we'll look at into the next one, that is the question number 54. The image formed by an objective lens of a compound microscope. Actually, the same question is also asked in the board exam of this year 2025. Okay, the right answer is, so you know it already, that is virtual and enlarged. Okay, so we'll go to the next one. Okay, that is question number 55. So here we have a prism. So okay, and what is given here is, so this particular angle R and R dash. Okay, and they have given a, okay, that is R is a function of the time. As the time changes, R also increases, and as a result, so what's the, okay, what's the equation for the R dash? So I'll give some equation, important equations. So I'll just, okay, so that is, what's the equation we have? R plus R dash equals to A, that is 50. Okay, and we have given the equation, that is R equals to 10 degree plus T square, and how the variation of, okay, how the R dash will vary. So therefore R dash becomes what? 50 minus the R, and we have to look at how the variation of the R dash with the time. So therefore first we have to look at the R here, so how it varies. Okay, and when you differentiate this particular one, so when you differentiate this particular function, what do you get? So dr by dt. Okay, dr by dt is just the, okay, 2t here, and as a consequence, so dr becomes what? So dr becomes 2t into the dt, and we'll get the equation for the r. So that is, when you integrate this, you will get it as, so t square divided by 2 into the 2. Okay, 2 will get cancelled, that is r equals to t square. And if we just substitute here, so what do you get? So that is 50 minus, okay, that is 50 minus t square. So that is the option 1 is the right answer. And 56, it is also a board level, okay, question. So we have a, okay, plane wavefront, so that is passing through the lens. Whenever it passes through, because it is a parallel beam, so okay, whenever we have a parallel beam, it will be converging toward, okay, converging at the principal focus. Okay, if that is the case, how the wavefront looks like? Okay, wavefront looks like it is a converging spherical wavefront. So therefore option 3 is the right answer. Okay, next. Okay, so the next one is total energy carried by light wave when it travels from rarer to, so this is, you have to look at rarer to non-reflecting, non-absorbing medium. So whenever it is non-absorbing, so that means it is not absorbing, means it's a, okay, and its energy remains the same. If its energy remains the same, so we can straight away we, okay, take it as, okay, the fourth option is the right answer here. And these are the very simple questions now. 58, so look at, radius of the Bohr orbit is r, then radius of the second Bohr orbit. Okay, okay, so that will be, okay, so here the radius is directly proportional to n square, and as a result, so what we can see here, if n, okay, second orbit antandre n equals to 2 agtade, so therefore we can straight away take this as the, okay, 4r is the right answer. Okay, okay, we'll look at the next one, that is the 59 here. So there's a, okay, in the column 1 we have isotopes, isobar and isotones, and we have to match. So what are isotopes? So okay, these isotopes will be having the same number of protons. Isobars, okay, will be having the same atomic number. Isotones will be having the, okay, that is the same, okay, neutron number. As a result, so as a result, option 3 will be the right answer. Okay, the next one, last, which of the following statement is incorrect with respect to the nuclear force? Okay, for this particular one, you should remember this one graph, that is nuclear potential energy versus the distance. Graph looks like this. Okay, so at this particular point, so potential and nuclear potential energy becomes minimum here. Okay, in this particular, okay, range, what we can say, so here it becomes attractive, and in this particular case, whenever the nuclear potential energy becomes positive, it becomes repulsive, and here it is actually attractive, and the potential energy is minimum at this particular point. So based on this, force can become attractive and repulsive. Okay, so therefore which one is the incorrect one? So incorrect one is the nuclear force is always attractive. Okay, so we'll try to look at Okay, so we'll slightly look at, okay, we'll look at this question number 55 again. So here, so that is r dash, we have taken this as the 50 minus r, okay, and so we'll straight away will okay substitute the equation, and as a result, so we'll get the okay result here, but we have done in another way. So we'll just rub this particular part. So if you just substitute in the above equation, so what do you get? So r dash equals to 50 minus r. So we have the r is already, we have the equation. So okay, and this particular part unnecessarily we have done the differentiation and the integration, and as a result, so r dash equals to 50 minus okay 50 minus 10 plus t square, and as a result, so we'll get the answer as 40 minus t square. So make a correction in this particular one. So that is not the 50 minus t square. So that is actually 40 minus t square. So that is the right answer. Make a correction in the question number 55. Okay, that is option 3. 40 minus t square is the right answer. Okay, not the okay option 1. Okay. So therefore, so we completed the okay paper discussion. Okay, thank you and all, and please subscribe our